Section 5.4 is about properties of integrals, and I have them listed here, but we'll go through each one briefly. The first one, integral of a constant, you already know this one. If your integrand, this k, is a constant value, like a 2 or 12 or a negative 68, then you can just apply this property. We learned that this just creates a rectangle when it's graphed. If you do b minus a, that will give you the width of the rectangle, and the k gives you the height, so it's your base times your height, just the area of a rectangle. Property number 2 is the reversal of limits. When you are given an integral, the lower limit is the lower number, and this is because your limits represent an interval, and when you write an interval, the lower number comes first. So if you see your limits reversed, you're allowed to switch them and put the smaller number as your lower limit. What that's going to do is put a negative in front of your integral. The third property is my personal favorite because it is so simple. It's called the zero property. This is for when your limits begin and end at the same number. And if you think about it, it makes perfect sense. If you begin and end an interval at the same number, then you will have generated no area, and therefore your answer is 0. Property number 4 is called the sum and difference property. This is for when your integrand consists of two functions, either being added or subtracted. What this says is you're allowed to give each function its own integral sign. Notice that the limits don't change. They go from a to b on that original, and on each individual integral, they still go from a to b. You would choose the appropriate sign, either positive or negative, and carry that sign in between the two integrals. Property number 5 is the constant multiple property. K is representing a constant in this. This property says if you have a constant times the function, you're allowed to take that constant and pull it to the outside of the integral, write it out here, and then just focus on doing the integral of the function. Property number 6, additivity, is allowing us to take two integrals and combine them into one. What's key here is where one of them ends, the next one picks up. And if you think of these limits as intervals, it makes perfect sense. If you take an interval from a to b, and then another interval that begins at b and runs to c, and I'm just pulling these intervals based on the limits of the problem here, that would be the same as doing one big interval that runs from a to c. And again, the key here is where one of these integrals leaves off, the other one begins. Property number 7 is for even functions only. Recall what an even function is. It's a function that is symmetrical about the y-axis. I have an example of one right here, this quadratic. This y-axis is a line of symmetry. What appears on the right is a mirror image of what appears on the left. If I look at an integral of this type of a function and my limits are symmetrical, meaning this is a negative a and this is a positive a, so it's negative 2 to positive 2 or negative 8 to positive 8, so it requires you to have symmetrical limits. The area that's generated from 0 to a in this region, because of this property of being even, that area on the right side of the y-axis will be exactly identical to the area that is on the left side. If I just look at this area over here and double it, it will be the entire area that runs from negative a to a. Our last property is for odd functions only. Odd functions have symmetry about the origin. What this means is when I plug in a negative of an x value, it's going to give me the negative of the y value. So if I plug in a 1 and it gives me a y value up here, when I plug in a negative 1, it's going to give me the exact opposite of that y value. Your graph is going to look something like this. If I look at the integral from negative a to a, and again, I'm requiring these limits to be symmetrical, so from negative a to positive a, the area that's generated from 0 to a, this green region, will be positive, and the area that's generated from negative a to 0, this yellow region, will be the same area. However, because it's below the x-axis, it will be negative, but other than that, it's going to be the same amount. So the negative and the positive are just going to zero out, and the value of that integral will be 0. Let's take a look at some examples, and you'll see how these properties work. In this first set of examples, I'm given values of different integrals, and there's two different functions going on. So these two are for function f, these two over here are for function h. Question number 1 asked me to use this information to evaluate the integral from 0 to 7 of f of x dx. I see that my f of x integrals go from 0 to 4, and this one goes from 4 to 7, and I'm asked to find from 0 to 7. What I'm going to do is piece together these two given integrals to equal this one, which is property number 6. Using that additivity property, my limits here go from 0 to 4. Notice that my next integral picks up with the 4 and runs to 7. This will be the same value as the integral from 0 to 7, which is what my problem is asking me to find. Subbing in my given integral values of 8 and negative 3 and adding them together gives me an answer of 5 for number 1. Looking at question number 2, I see that the limits are backwards. The lower limit should be the smaller number, and it's not. So I'm going to use that reversal of limits property number 2. I'm allowed to switch them around, but that requires this negative out in front. The value of this integral from 0 to 4 f of x dx is the 8. My final answer here is negative 8. For question number 3, the sum and difference property number 4 allows me to split this into two separate integrals, both of which will have limits that run from 0 to 4. Once I do that, I run up here to my known integral values. I see that the integral from 0 to 4 f of x dx is this 8, and the integral from 0 to 4 of h of x dx is 2, and 8 plus 2 gives me the answer of 10. Question number 4 is asking me to evaluate the integral from 0 to 4 of 2f of x minus 3h of x dx. I'm going to use the sum and difference property number 4 to first of all split this into two separate integrals. Using property number 5 next allows me to pull the 2 and the 3 constants to the outside of the integrals. Once I do that, I can see that my integrals are matched up to my known values. This one from 0 to 4 f of x dx is 8. This one over here, 0 to 4 h of x dx, is a 2. And I'm just going to substitute those values in and multiply and subtract, and that's going to be my answer. I get a final answer of 10 for that one. In question 5, I see the limits are matching. This is the 0 property that says if you have the same limits that you're not generating any area. My answer here is just a 0. No further work or explanation is required, and I'm sure that one is your favorite property now too. In question number 6, I'm going to piece together my three h of x intervals according to the additivity property. There are different ways to handle this, but I like to write an equation that piece together the pieces according to that property. So from 0 to 4 plus from 4 to 10 equals from 0 to 10. Then plug in your known values. And then just treat this like an algebraic equation, and I'm solving for this piece right here. So I'm going to subtract the 2 from both sides. I get that that integral is equal to a 10. Question 7 starts by telling me that f of x is an even function, so it makes sense. I'm going to use the even property. That property just says if I know the area from 0 to 4, I just double it, and that will be the area from negative 4 to 4, which becomes 2 times 8, giving me an answer of 16. Question number 8 lays out that h of x is an odd function, so I'm going to use the odd function property here. Because my limits go symmetrical from negative 2 to 2, I know that the area that is going from negative 2 to 0 is going to balance out the area from 0 to 2, and this is just going to zero out, and that will be my answer. Question number 9 goes back to that even property. What I see here is I do not have the symmetrical limits on this one, but I can split this apart using that additivity property so that I do have symmetrical limits. What I did was I forced the symmetrical limits to happen here, and then just the excess beginning at 4 and running to the 7 sets me up this equation. This answer to this first integral from negative 4 to 4 f of x dx, that's just my answer from number 7. And the value of this integral is one of my given values, which is negative 3, which gives me a final answer of 13 for this one. Question number 10 is a type of question that tends to stump people. What people want to do is evaluate this integral from 0 to 4 f of x dx. We know that's 8. then just add the 2 and write your answer as 10, but that would be incorrect. When you're doing it that way, you're treating this plus 2 as if it were not part of the integrand, and it is. I'm going to start this one by splitting this apart using that sum and difference property. The value of this first integral is given as 8. I'm going to use the integral of a constant property to evaluate the second integral. I start by finding the difference of my limits, which is a 4, and then multiplying by that constant function, which is a 2. And I get this is actually 8 plus 8, giving me a final answer of 16. These last two examples are a little tricky. They're something that you would find on an AP exam, and I just wanted you to see the variety in how these could be asked. In question number 11, I'm given an integral equation. I'm asked to find the value of this integral over here. I'm going to use the properties and treat this integral kind of like a variable and solve for it. Let's start with the sum and difference property and split this over this addition sign. I'm going to keep this in its equation form. I'm going to try to solve for this integral right here. My next move is to use that constant multiple property. I'm going to pull the 3 out. An integral of a constant here, which is 5 minus 1 times the 4. So now I'm just going to treat this as an equation, and I'm solving for this piece of information right here. So now if I'm solving for this yellow box, I'm going to start by subtracting the 16 from both sides of this equation, and then dividing by 3. And in doing that, I solve for that integral that I was asked to find up here, and the value of that integral is 6. The last question is a little tricky as well. When you first look at it, you may not know what to do, but what strikes me first is the limits of these. These are going from 0 to 10, 0 to 10, 3 to 10, and 0 to 3. So it looks like I'm going to involve that additivity property of adding little pieces together. So let me start by doing that. Similar to what I did before, I'm going to treat this as an equation that I'm solving for this piece right here, because that's what this question is asking me to find. So let me see if I can fill in the other pieces. I see this integral value right here, the integral from 3 to 10 of f minus g, is exactly up here. That value is given as a 2, so I can replace that whole integral with a 2. So some things I did here in the next step. I know I'm solving for what I have boxed in red right here. If it's too much to keep writing that, if it looks too messy or complicated, you could always just substitute in an x, knowing that that is what I'm trying to find. So that's an option for you. I do know that the value of this integral was given as a 2 up here, so I just replaced that whole chunk with a 2. Over here, what I did on the right side of the equation, because the integrals from 0 to 10 are given as separate f and g values, I went ahead and I used that difference property and I split this up into 2 integrals. And this first one, this integral from 0 to 10 f of x dx, is exactly what this first statement up here says, and its value is 21, so I'm going to substitute that in. Now this piece is not quite so easy because I have that 1/2 there, so I'm going to go off to the side. I'm going to play with this one a little bit to see if I can clear that 1/2. First, I'm going to pull that 1/2 out in front of the integral, and now I'm just going to solve for this integral, 0 to 10 g of x dx, so that I know what to put down here. Multiplying both sides by 2 to clear that 1/2 gives me the value of that integral is the 16, and that's what I'm going to substitute in for this red box right here. From here, it's pretty straightforward to solve this. I'm solving just for the x. Finishing out solving this equation gives me an x value of 3. Keeping in mind that what x was representing was this whole integral that I was asked to find initially. And I get the value of that integral is 3. There are different ways to go about solving this. You do whatever works for you. I find that it's just like piecing together a puzzle, just putting the pieces together, using the properties. Sometimes initially you may not see exactly where you're going, but then the steps emerge as you get further on. If you need help, come see us and good luck.